Kia ora, everyone. Welcome to our webinar today. Thanks for making the time to join us for another midweek webinar. Nice to have you back with us once again, or if you're a first-time visitor, thank you for joining us. So we will go ahead and kick things off here today. Thank you so much, Tina katoa, and thank you for joining us once again today. So if we haven't met, my name is Kevin Patek. I'm the Manager of Marketing and Communications here at Te Kahui Whaihanga, the New Zealand Institute of Architects. And it's great to be with you all today. This is my second stint as an Institute webinar host. So as an alternative title for today's session, it's Kevin Patek Strikes Back. Welcome along and thanks for joining. Today's session is the first in our new design and innovation series sponsored by ECC. So of course, I'd like to very much start today's session by thanking them for their support of the webinar series. ECC is a leading provider of contemporary lighting, furniture, and accessories. So please, if you have the opportunity, check them out as a way to say thanks for making today's session possible. It's now my pleasure to introduce our panelists today, Nick Clements, who will be our speaker. He's a first-time presenter in our webinar series, so thanks, Nick, and I'm looking forward to hearing from you. If you don't know Nick, he is the inaugural winner of the NZIOB Digital Technology Award for his work on 3D estimating in residential construction. He's a member of the NZIQS and is vice chair of the Auckland Committee in Tamaki Makaurau. Now, his business, YourQS, specializes in cost estimating services to residential builders, architects, and homeowners for both new build and renovation projects. They've completed over 3,000 projects for around 300 builders since launching in 2019. And if that wasn't enough, turns out that he is also a podcast host. So available wherever you happen to pod. He is the host of the Beyond the Guesstimate podcast. And his topic today with us is creating cost-effective, thermally compliant designs, which I'm sure everyone will be keen to learn more about as we head into the cooler months ahead. Nick, I will now hand over to you, if you'd like to please take it away from here.
Great, thanks, Kevin. I appreciate the intro, and thanks everybody for taking the time to listen to me. And I'll, over the next sort of 40 minutes or so, I'll take you on a bit of a journey and sort of give you a bit of a background of my story and the story of the business, and then this whole area of what we've been doing in H1. So just looking at the presentation outline, so I'll start off by just talking a little bit about H1 and the cost impacts and some of the research we've been doing around that. I'll give you a bit of background to YourQS, just to give you an idea of sort of what we do and why I'm saying the things I'm saying, and take you into a concept that I've called cost-informing design. So it's sort of the ethos behind our business, and as you'll see, I've realised that it's ethos behind a lot of what I've been doing for the last 20 or 25 years. And then we'll spend a bit of time on just a new service that we've been working on. That this is basically the launch of a service for cost-effective H1 compliance. And then, as Kevin said, we'll have a bit of time at the end for questions. Just talking a bit about the background of YourQS. So started in 2018, so we've been running about 7 years. As Kevin touched on, I'm a registered QS, member of NZIQS, and won that award, which was very nice. And we've got a team of 12 based here in Auckland, and we service all around the country. We work with about 300 builders, and we help them and prepare their quotes for their clients. So we're basically working hand in hand with the builders to help them prepare their documentation that they are then pitching to their clients to hopefully win the job. And then we also do quite a bit of work with architects, designers, and homeowners, particularly focusing around sort of early stage concept type work to help them understand the cost of the build before they get too far into it. And as I guess you probably picked up through what Kevin and I have been saying, what the big point of difference between us and traditional quantity surveyors is we developed our own software, and it is all based around using 3D. So this H1 journey for me started at the Constructive Conference in Wellington last year, where I was talking with Matt Duda from eBOS and Matthew Cutler-Welsh around this that was in the media at the time. So Chris Pink saying that H1 had added 40 or 50,000 to the cost of houses, and government were looking at wiping it. And the feel from us and our customers and both Matthews was that didn't really make sense. And so we kicked around some ideas, and so Matt said, well, why don't you do a bit of work on it, and we can publish something in eBOS. So you may have seen that at the end of last year where we did some work, actually working with certified builders on a couple of their standard plans. And that definitely threw the cat amongst the pigeons in terms of that $40,000 to $50,000 cost. In our view, it wasn't that much. And we then started talking to brands and looked at that consultation that came out earlier this year and managed to get these 3 plans from brands that were what they'd used for the costing work that had been done by a couple of other traditional QSs as part of that MB consultation. And basically we looked through these designs and started playing with understanding what the costs were of the different options to be able to comply with H1. And we spent a bit of time just working through a whole bunch of different scenarios. At that stage, we were comparing them with the schedule cost to try to look at what is the cost impact versus the schedule. And what we found was the design choices that are made through the compliant process. So all of these different ones you see on the screen here all comply with H1, but you can see there's quite a wide range of costs and quite a variance to what the schedule method does cost. And so that said to me that there's an opportunity here for us, because the challenge for designers is you might be able to work out whether the design complies or not, but you don't really know what the cost impact of your decisions are. So that was the single story one. This is the double story one. We also looked at a terrace house, so we looked at the mid unit on a terrace house, and the pattern was sort of broadly similar. But one thing that came out of it, which sort of helped me realize that there was an opportunity there for us, was you couldn't take the same choices and apply it across all the different designs. That they did move around a bit. So the characteristics of the design affected as to what is the most optional cost alternative to use. So it meant that said to me, well, hey, it's not actually an easy decision-making process for a designer to be able to do. And so we started doing this work on the service that we're in. So yeah, I guess why believe me? What's the credibility behind what we're saying? So I'll give you a little bit of my background. I started in the industry in 1993. So yep, I'm an old bugger. As marketing manager for Carter's based down in Hawke's Bay. And back then we had group builder customers. And part of my role was to set the national pricing for the various group builders that we had that sort of went across multiple branches. And back in those days, that a lot of it was based around standard plans. So each of the group builders would have 30 or 40 standard plans, and they would largely build those plans pretty much unchanged. And so we had to have a price list for them for all the frames and trusses that were used in those different standard designs. And at Carter's, we had 8 frame and truss plants. And what I would do is work with one of the local plants near us in Napier to set the prices, and then we'd distribute it to all the other plants. And I'd have one happy plant and 7 plants complaining at me. And I thought, this doesn't really make sense. You know, we're one company, yet our 8 plants can't agree on what the price is. And so what I did was sent a set of 3 plans, a basic house, a medium house, and a bigger house to all of those plants, and got them to price them and give me their pricing, but not only give me the price, but give me their methodology for how they work the price out. And I found that I had 8 completely different answers. So all of the 3 plans the prices were quite a variance across those branches. And there were 8 completely different methods as to how they worked out the price. And I thought, gee, there's got to be a better way than this. We're one company, you think we could do something better. It also sort of got me thinking that the communication from designers to us was pretty difficult. So back then, it wasn't even floppy disks or USBs. It was paper. So they'd be printing out the plans and sending in a courier and a big stack of paper, and our guys would then be costing off that paper into our systems. And that got me thinking that when you look at it, most of the designers then were using computers, but they were printing it out on paper from the computer, and we were using computers for the frame and truss design and also for our costing. I thought, surely these computers can talk to each other. Now, you've got to remember, I might be, I guess, IT literate now. Back then, I was barely so. I could send it, well, it wasn't even emails back then. I could type a letter, and that was about the limitation of my computer knowledge. And so I thought, well, yeah, why can't they talk to each other? And what I've subsequently learned was that really exposed how little I knew about computers, and it wasn't actually that easy. So the concept itself was quite easy to describe and easy to see the benefit from, but the practicalities of actually making it happen are pretty challenging. And through that, what it made me realize was there was a big disconnect between when a design decision's made and understanding the cost impact of that design decision. And so you go back then where it was printing out on paper and stuff had to physically move around. It was quite a long time before that it was understood. But even today, where things, we can email plans to people, it's still quite a disconnected process. And I believe there's a big opportunity for the industry to bring those two things close together. So the sooner a designer or a decision maker can understand the cost impact of those decisions, for me, the better decisions they'll make and the better understanding and the better outcomes we'll have in terms of buildings. But for that to work, the costing methodology has to be refined enough to respond to those changes in design. And that was sort of something I found with traditional estimating, that when you're measuring off a plan and using square meter rates for a whole lot of things, a lot of the smaller details in the designs that do have quite a material cost impact get lost in those square meter rates. And also those square meter rates, if the QS that's doing them is any good, they're manually adjusting those square meter rates to reflect the characteristics of that particular design, but they're doing that subjectively. So they're making decisions from their experience. So it means the results are quite variable between estimators, and even the same estimator between time of day. If they've had a bad Monday morning versus a happy Friday afternoon, or you give the same job to an estimator 6 months later, you're probably going to get a different answer just because of that subjectivity. So I came up with this concept that I've called cost informing design, and it's about creating that closer connect between the design decisions and the impact of those decisions. And so it's not about designing to a cost. It's not trying to necessarily drive cost out of the process. I want to drive efficiency and drive cost out through doing that. But it's about having an understanding of the cost impacts of those design decisions. So I've called it cost informing design, and I realized over time that is the underlying ethos of what I've been doing for the last 20 odd years in my career. So as I touched on, the cost's got to be accurate for that to be any good. And so I, way back then, came up with this idea of using 3D models to drive the costing process. And I first started working on this 2001. I was still with Carter Holt Harvey and managed to pitch to them the idea of a project. And back then we looked at what design tools were around, and ArchiCAD was the sort of leading technology. And I felt right early on that it really needed to be 3D, because 2D doesn't have enough information in it and requires a lot of reprocessing. And so I pitched to Carter Holt to build a system that would basically drive, and we were looking particularly at the frame and truss part of the process, as being able to drive the costing of frames and trusses, and in fact the engineering of frames and trusses, directly from the ArchiCAD model. And we had a decent nudge at it, spent 3 years, spent $3 million of Carter Holt's money, trying to make that work. And we actually, when I look back now, I realize how little I knew about software development when I did that project. What we did was, in hindsight, was actually pretty stunning. So in 18 months, we actually had a system out there. They'd asked us to look at kitchen design. So we actually built a kitchen design and manufacturing system. And I thought, oh yeah, why not? It's a subset of a house, so we're going to need to do it at some stage. So let's start with kitchens, not realizing just how complicated kitchens were. And so we got a system going. We had 25 customers using it. But unfortunately, I had 5 different managers over the 3-year cycle of the project, and we're talking 2004. Carter Holt was starting to struggle, and basically anything that was costing money and they didn't see a future for it as far as Carter Holt was concerned got chopped. So I got chopped, and that was my 6th time of having my role made redundant at Carter Holt. So I decided to leave and started my previous business, where we started building out this idea to use what we'd learned from the experiment, effectively what it became at Carter Holt Harvey, to drive this process. So your QS is sort of the ultimate expression of that many years later. So what we've done with your QS is, instead of trying to derive it directly from the ArchiCAD model, which we found had a whole lot of issues. So one issue was we did so much development inside ArchiCAD that every time they did a new version of ArchiCAD, we were spending $80,000 or $100,000 upgrading all of our plugins to keep them up with the new version. And I can just swallow that. And ArchiCAD back in those days was doing updates maybe a minor one every 6 months and a major one every 12 months. And so there was a lot of work just trying to keep up with it. But also I realized that the only way our process would work was if it started in ArchiCAD, and not only that, if it had to start in our version of ArchiCAD, because we'd modified it so heavily. So when we left and started our own thing, we realized, well, we couldn't afford to spend the amount of money inside ArchiCAD that we did previously. And we also wanted to avoid this whole issue of the upgrading and being so dependent on the development capabilities of these WahiCAD in particular. And so we came up with another idea, and by then Revit had started appearing on the landscape. So we did actually consider Revit when we were looking at the whole project. At that stage, it was before Autodesk owned it, and yeah, it wasn't really suitable. Something's happened with my headset, so somebody yell out if anything's changed at your end. So I'll carry on in the meantime. So we decided to come up with a method where we've developed lightweight plugins that go into both Revit and ArchiCAD that allow us to expose what we can make use of out of the 3D model and bring it across into our system. We also realized that most of the industry is the communication is via PDF. So we had to build a solution to be able to work with PDFs. And what you're seeing on screen is the tool that we've developed for doing that, which we call Rapid BIM. So it's purposely built 3D modeling tool for the objective of creating costing. So it's not a design tool. It's got a lot of limitations from a design and visualization perspective because it's built for the purpose of creating costing. If we look at what's on screen, on the left-hand side is what we call template elements. So those are the elements that are available to the user to be able to place into the model. What you see in the middle of the model is the model of what's being placed in by the user. And then on the right-hand side gives us all of the elements that are in the current view. Each of the elements has properties and lists on it, or metadata is the technical term for it. So these are similar to attributes in Revit, and I think ArchiCAD also call them properties. So what we do is attach this metadata to each of those elements, and we've got structured lists of information. So we've got drop-down lists for all the different pieces of information that we need to know about those elements. And our costing process is a combination of the geometry from the elements and this metadata that tells us who's making the element and what it's made from. So in this case, I've dropped down the list of cladding. So we've got a choice of different cladding materials. And then what we're able to do is basically push a button and it works out a cost directly from that 3D model. So the combination of the geometry and the metadata goes through a process which looks like this. So behind each element is what we call an assembly, and we represent that assembly as a flowchart. And what our system does is basically navigate through that flowchart, makes decisions on what needs to be included, so what costs are included, and those costs could be labor, materials, sub-trades, overheads, equipment, whatever's needed. And so each element, when we generate the costing, it goes through this process for every element, for every instance of it in the project. And from that builds up a schedule of material, or a schedule of costs, a schedule of items that we then apply rates to develop the costing. So this is a big difference to the traditional estimating. So how I describe it is our organizational knowledge about how you cost buildings is in here. So all of our team, they're not having to look at a particular element on a building and think, oh, it's going to take 2 days to build that, or it's going to take 4 hours to stick this door in. All of that information is built into these assemblies. We've spent a lot of time working with builders and getting feedback from them, refining the labor times, refining the materials to try and get it as accurate as possible. And because it's captured in here, basically once we figure out an issue and fix it, we stick it in here, and every job's going to be exactly the same if you have the same inputs going into it. So when we first got the service going and we were generating a costing structure out of the 3D model, we were basically handing it to builders and saying, hey, here's your costing. It's come from a 3D model. Yeah, it's good. Don't worry about it. It's perfect. And they would say, well, we can't really understand what you're doing. We can't understand what you've included, what you haven't included. And sort of talking with them, I realized that there was sort of 2 issues involved in this. So one was us explaining to the builder what we'd allowed for and what we hadn't, but also the builder taking our information and then presenting it to their clients, as they had as much of a challenge explaining to the clients what was included and what wasn't. And I thought, well, we've got this 3D model. How can we share the 3D model through this process and use that, picture tells 1,000 words approach with the builders, and then give them the ability to be able to give that to their clients. So we came up with this PDF report that was our core output from our process since we started the business. And behind that, we ended up coming up with I guess you could call it a work breakdown structure. So things like master specs, CBI, the old common arrangement of work sections type approach, doesn't really work with the BIM environment, doesn't really work with 3D modeling. And so we had to come up with a way of being able to sort of open up the model and allow the user to sort of find their way through it in understandable chunks. So we came up with this that we call these work areas. So we break the model into work areas, which is sort of broadly the construction process. And then within each of the work areas, we have what we call a scope. So in this case, the scope is the exterior walls. And what we do is, as we're modeling that scope, is we take a screenshot of that, what's in that scope. So there's a visualization of it. There's, if needed, there's a written description. We generate this schedule of elements, so it gives the reader a list of every element that's in it and some key basic information. So maybe some of the attributes, maybe areas, some of the key measures. And then we then show in the report for the builder or the person wanting the cost breakdown, we then show exactly how we've arrived at the costs that make up that particular scope. So it summarizes all of the different components, materials. So you can see here, we're getting right down to how many bolts there are in it, how many nails, the carpenter's labor, and all of that's driven from the 3D model via the assembly. Then for the builders, we actually created what we call a client report. So a client version of this report, which has the same sort of structure, has the same pictures, gives them that same description of the scope, but doesn't include the cost breakdown. It just gives them the total price for that scope, including the builder's margin and including GST. Whereas these numbers here are the builder's buy cost, and then we apply the margin GST to that. So as Kevin mentioned, we've done over 3,000 projects since we kicked off in 2018. I started off in my downstairs bedroom thinking I'd have a work from home business. And when I got to 5 people jammed in that downstairs bedroom, I thought it was time to get an office. And yeah, we've been a team of sort of 10 to 15 over the last few years. And as you can see, we work all over the country. We've done projects for, on a wide range of constructions across most areas of New Zealand. So looking at this thermal performance area, so the whole thing behind H1 is looking to create a minimum standard for the thermal performance of new houses. And as you all know, it's section H1 of the building code. What the basic assumption behind the code is that your design must perform better than a reference design. And you can demonstrate compliance by a few different methods: the schedule method, calculation method, and modeling method. But when we start, so schedule method is the easiest way of complying. And when we see jobs coming through, it certainly would be the most commonly used method that we see because it is pretty easy to do. But the consultation and part of that discussion that I alluded to earlier on about with Chris Pink, et cetera, was questioning how effective the schedule method was. And certainly that cost analysis that we did showed that it wasn't particularly cost effective in terms of achieving the desired outcome. So I think it's pretty likely that the ministry will go with their recommendation of removing schedule method as an option. Calculation method's a bit more involved, but gives you as the designer a lot more flexibility. So you don't have to have a minimum requirement on each element. You have to have a minimum overall performance, and that gives you the options of being able to play where effectively you spend your money in the different bits. So you've got to look at the walls, floors, roofs, and glazing. You work out a construction value for each of those surfaces, and then from that, calculate the heat loss of your proposed building versus the reference building. The formula defines the calculation that's used to do that. So this is the calculation for the reference house. And the main difference between the reference house is the assumptions on the window versus, or the glazed area versus the total wall area. So it's based on a 30-70 split. And that's part of where some of the ability to get flexible comes from, is if your window percentage is different, you have some more options around how you comply. But the underlying R values are the same R values as what's in the schedule method. And so we then, on the proposed building, you then do this calculation, which is basically the same thing, but using your areas and your building specific R values to do the calculation, and you compare the two of them together. One of the challenges is determining the thermal envelope. So you can't just use the areas out of your 3D model. So it's pretty easy out of most of the 3D design systems to get the areas out of them. The reason why you can't use the areas is, say, this example here, where the house on the left has got a raking ceiling, the house on the right hasn't. The end wall is a gable wall. So some of that gable wall is going to be inside the thermal envelope and some of it's going to be outside. So if you use that gable wall area, it's going to be wrong. So right now, what I see with most people that are doing this process is they're manually measuring over the plans to work out the areas that apply for the thermal envelope. And obviously the thermal envelope is the part of the building that keeps the inside away from the outside. And you've got to work out the wall areas, the glazed areas, and then within doors, you've got to work out the glazed portion and the opaque portions of the doors because they've each got different thermal performances. It considers whether buildings are conditioned spaces or not. So things like garages may or may not be a conditioned space. So your thermal envelope is the conditioned part of the building. So that means some of the walls might actually be interior walls. So obviously most external walls will be part of the thermal envelope, but some interior walls might be also. And then when you get to multi-story buildings, or sorry, being the wrong key, multi-story buildings or split levels, that sort of thing, it gets more complicated because the mid-floor is not part of the thermal envelope, it's inside the thermal envelope. So getting all of that out of your 3D model, getting it out of your design isn't trivial, it's a bit of work. And then the other thing that needs to be determined is the construction R value. So that's the thermal performance of each of the elements. And that's made up by looking at the conductivity of each of the components in that element, and then how much of that element contributes to the thermal performance of that particular element. So if we look at the plasterboard here, that goes across the entire wall, so that means it's going to have 100% contribution to heat moving through it. But something like the stud is only affecting the width of the stud, and the insulation only affects the area between the studs where the insulation is. So to get the thermal conductivity of this layer, you've got to work out what proportions contributed by the stud and what proportions contributed by the insulation. And then when you get to the outside, you've then got the cladding, which is back to the 100% again, but you may have cavity battens, which are only 40 mil wide. You may have an air gap. There's a whole bunch of things that go in there to be able to calculate that out. And this is sort of something I've come to realize as I've been working on this and talking to people, is that this insulation part of it is only one leg of really what's a three-leg stool. The standard sort of mentions air tightness and ventilation in passing, but doesn't address it. It just focuses on insulation. And ideally, you do need to think about the other parts. And I'll sort of give you a bit of a reason why. So if we look at that, that wall example where we've got timber stud but with insulation in there, plasterboard and cladding on the outside, the house inside's warm, the air outside's cold. And so what that means is, from a physics point of view, is there's a temperature gradient through that element. So as you take any point through that wall, the temperature is going to be somewhere between the inside temperature and the outside temperature. And what happens is, as each of the thermal characteristics of each of those layers affects the temperature, it steps down through it, and it starts at the edge of the wall. So it actually starts outside the wall. So the air that's sitting next to the surface on the inside and the outside of the wall actually changes the thermal conductivity because the air doesn't move. There's like a laminar layer that just sits on the wall. So that actually contributes a little bit to the insulation performance. And then you step through, and the steepness of line shows, or what I've depicted here is it's showing the thermal conductivity, so not thermal resistance, but the thermal conductivity. So the more conductive it is, the faster the temperature will drop going through that element. So say the plasterboard is going to be more conductive than what our combination of timber and insulated wall is. Then you've got your rigid air barrier or cavity batten or whatever is going to have another value. Then you've got another value there, and then you've got that same laminar thing outside. So it means that it has to be a line. It's not a straight line between the inside area and the outside area. It's a gradient like that. And why that becomes critical is there's a temperature called the dew point, and at the dew point is where you get 100% humidity, so you've got the ability for drips or dampness to start forming. And if that dew point happens to be in the middle of your wall, then you've got the potential for the warm, moist air inside the house to cool to that point and start forming moisture in the middle of wherever it is. So to get around that, we have to control the movement of that air. So we put an air barrier, a vapor barrier or an air barrier in to keep the damp air inside. It doesn't keep the temperature in because the vapor barrier will have minimal impact on the thermal movement, but it keeps that moisture inside. And then we can't just do that because it'll get moldy and damp inside. You've got to then consider ventilation as part of that. And where we experience this the most is if we look at that same sort of chart. So say we've got something like a window, or if this happened to be a steel framed wall or something that with very poor thermal performance, then your gradient's going to look something like this. And that means your moisture point ends up being, or your dew point ends up being on the inside of the building, right close to where this line is going from the inside air down to the dropping temperature here. And so that's why we get constant condensation on the inside of windows. So that's just a bit of theory behind sort of how thermal conductivity and stuff works. Just looking at how the calculation method works. So here's our reference building. This is showing the performance of the reference house using our areas. This is the heat loss using our R values. And then this is the result. And as part of the code, is if any particular element is less than 50% of the R value of what's in the schedule, then it'll fail. And if the heat loss of the building overall is too low, it'll fail as well. We've got modeling method as an option, so that's the third way of complying. Modeling method is definitely the best way of doing it because it gives you the most amount of information. So it actually models the thermal performance of the building. So we'll give you heat gain, heat loss, energy calculations. Most of them now are giving you carbon footprint calculations. But there's a few challenges to it. So one is it requires software that's approved to a standard called ASHRAE 140, which is like about 300 pages of proving your building or your software complies with a whole lot of standard calculations. And obviously that software costs money. It takes time to input the building into it and does need an amount of skill to be able to use. So it's definitely a valid scenario, a valid thing to do in some situations. So the result of it, no matter which method you're complying, other than the schedule method, is you've got a whole bunch of levers that are available to you to be able to make your building compliant. So what materials, the shape of the building, the dimensions of the building, the ceiling height, the size and number of windows. And each of these decisions that you make have a cost impact. And what we've identified is understanding that cost impacts very important, but it's not that easy. So our system supports most of the New Zealand common construction methods. So you saw that assembly that I showed you earlier on. So within that, covers most of the ways people build houses in New Zealand. And this wasn't every option in there, but the sort of main ones related to the thermal decision making, so related to H1. So you can see we've got 35 million permutations of how you could build a building. And our system the way our system works, that can cost all of those 35 million, but it's obviously very difficult for anybody to be able to know which is the optimal choices to be able to make. And then of course you've got your design choices. So being able to understand the cost impacts of those decisions is pretty challenging. So if we come back to what I was talking about with the closing the gap, so we've got our PDF approach with Rapid BIM, and we create what we call visual costing, so the ability to be able to see the 3D model and costs together. And we've got our plugins that we've branded as BIM to your QS that allow us to bring the Revit ArchiCAD models into Rapid BIM and then deal with any issues that we need to deal with and get them into the structure so we can do the costing process. And from that, we've now developed this new service that we're launching right this moment called H1 Value Engineering. Nice little whizzy thing that PowerPoint does. So that's the website for it, h1ve.co.nz. And it's very much in the ethos of this cost informing design and looking to try and bring the decision and the cost impact closer together. So to help designers understand the cost impacts of those decisions they're making, focusing on the H1 use case. So if we look at our system, so we've got the floor, we've modeled the walls. So these are the exterior walls, but we don't need to do all of them. We only do the ones that are in the thermal envelope. And then we obviously got to do any internal walls that are part of the thermal envelope. We put in a ceiling. So we normally, when we're costing it properly, we'll put in each room because it costs more to do a small room than it does to do, say, a big area like this. But from an H1 point of view, it gives us the information that we need. And then we also create what we call a zone, and the zones hold the interior lining. So the information about what lining it is on the walls, what the floor covering is, what the ceiling is. And from this, we create what we're calling the thermal envelope. So we've developed a tool set that allows us to interpret the walls, identifies what technically is called a closed polygon. So it identifies where all the walls meet, creates a polygon, and then projects the thermal zone off that information. So it saves us having to manually model it. And then also what it does is that each of those thermal surfaces look out to see if it can find the wall, and then finds what wall it is, gets the R value off that wall, puts that onto the zone using the area that overlaps. So we can basically work out an average R value for each of those zone surfaces. It also gets the area for the windows and projects those on, so we can work out the net wall area for that thermal zone without it. So all of that's done by my smart guys figuring out 3D geometry to be able to work all of that out. It's a feature so that was ArchiCAD's had forever. There's a magic wand, so space click. So with ArchiCAD, you can go over a wall and do space click, and boom, it'll identify all the walls that form a polygon and then create stuff off it. And so we thought, this is a little bit of an aside. So we thought, okay, let's see if we can find if AI can help us develop an algorithm to do that. And we said to AI, give us an algorithm that does that, and that's what AI gave us back. So AI helps, but you can't necessarily rely on it to be 100%. So then what we then built was this calculator. So this is our form of that calculation. So all those formulas I showed you are sitting in behind here. Along the left here is all of the thermal walls that are in this particular model, and then this is showing the calculation. Down the bottom is the one that matters, whether it's a pass or fail. Where it says conditional pass, that means that the wall may be underperforming on a heat loss point of view, but the building overall is passing. If you can still get a fail here, if say the wall is less than 50% of the R value, it'll give you a fail. If it's more than 50% of the R value, but its heat loss is greater than the reference heat losses, it'll give you this conditional pass. And as long as the overall passes, it doesn't matter that there's conditional passes in there because it meets the criteria. But if there's a fail here, then the overall will fail. So this is basically we're able to automate the calculation of this from the underlying 3D model. Part of our sort of process is we've built in a whole lot of validation checking. So we're able to click a button in our system, and we're continuing to expand the rules that the system goes through and looks for issues within the model. And so typically we've been focusing on things that are issues within our process, so like somebody's missed putting an image on the scope or that sort of thing. We're going to continue to expand this to build more and more intelligence into it. One of the things that our system does that has quite a big impact is automatically looks at junctions and walls and then determines off the orientation of how those walls are placed as to whether it's an internal or external junction. And the reason why we do that is junctions cost money. And so the particular junction details might be quite expensive, but even aside from that, every junction has more materials, more cost involved with it. So we're able to automatically identify those out of the model. And one of the things we ended up having to build was this, which allows us to graphically represent the direction the walls are going in. So when we started importing models in from Revit or ArchiCAD, we can't control how the walls are placed. Our guys know that our convention is anti-clockwise, but this allows us to see how they're placed and then correct them. When I talk about this service, it's something in the software world they talk about minimum viable product, and it's taken us about 8 months, and it's actually been surprisingly a lot more work than I was expecting to get it to this point. And so what we've been focusing on is what I've shown you now is what we can do now is we can offer a service where we can work out the H1 and understand the cost impacts and give you a view of different scenarios to come up with something that we think is a cost-effective way of doing it. So what we're doing with the minimum viable product is, you get something out there. We learn what we don't know. So through this process, we've learned a heck of a lot about whole H1 process, about some of the technologies and behind it all, and then also to find out if there's a market. So there is a degree of build it and they will come in this. I think we've got a good idea, but I guess it'll be the response from today will determine whether we've well, I wouldn't say wasted 8 months because there's a lot of value out of what we've done anyway. But it'd be nice to see that we've hit a market need. And just like at this point, say thanks to Ali Lakandwala. So Ali's been working with me. We brought him on board beginning of the year. He's an architect, but did a master's in architectural engineering at Canterbury. So it was a really good skill set for us. And he'd emailed me probably middle of last year, and it was a CV that sparked my interest. So I kept it aside. And when we put this project together, I tapped him and said, "You're interested in coming and helping us with it?" So he's been a great help in getting us through this and doing a lot of the donkey work. To win it to our minimum viable product, we've got a list of things that we want to keep looking at. So we want to get the service out. At the moment, the service will be send the information to us, either the H1VE, so either the BIM to your QS model or the PDFs. We'll then do the work and send you reports back. where we want to get to is building more into automation. And so at the moment, we've built a spreadsheet to be able to calculate the R value of those construction elements. Because we know in the model all of the information around what those elements are made from, so what the framing is, what the insulation is, we will be able to calculate out the R value from that. But there's going to be another fairly decent chunk of work pulling it together. We've also got ideas around the cost optimization. At the moment, we go through, find a complying design, hit the button, run the costing, which takes maybe a minute or two, then rinse and repeat. So basically go through. So there's a fair degree of manual judgment as to what the optimum is going to be. We think we will be able to get that a lot faster and potentially be able to run hundreds or maybe thousands of scenarios in the background and then present the user with a bunch of choices to say, okay, if you take this set of configuration, this is what the cost is going to be. So that's something we've got on the list. And it definitely just fits with the whole cost informing design thing, is what we'd like to be able to do is actually put all of this in the hands of the user, so in your hands. And what we'll be looking to do is have that ability to be able to push the 3D model from your system into our system and then render it to you via a website. And then you'd be able to do the interaction, be able to make these decisions and see the results quite quickly. So instead of having to wait for us to do it and send a report back, you'll be able to play with it yourself. So that's where we're looking to head. We'll see how close we get. And carbon, something that once we've got that in place and once we're working out the construction values, the R values, then carbon will be relatively straightforward to be able to calculate. So we'll look to add that into it as well. So I've just sort of described most of that. We're looking to kick it off with this pricing, and I guess part of the minimum viable product is testing if this works for the market. So we're looking to say it'll be $375 per project if you send us the BIM model via our BIM to your QS, or $425 if we've got to model it ourselves from the PDF. We've got a little bit of info on the website H1VE, which takes you through to our website, and Ali and I are working on a standard template form. So the sort of thing we want to be able to do is, there may be certain reasons that you don't want to use a particular product. So maybe you don't like polystyrene on site, or you're trying to achieve a green building value. So certain things aren't an option. So what we want to be able to do is you communicate to us what you don't want to use, maybe what your preferred option is, so we can cost your preferred option and then start doing comparisons for other options against that. So we're working on that, and we'll have that together pretty soon, and that'll be available from the website. For now, there's just a link on there that just allows you to send us the drawings and whatever other information. So Kevin, here we're 12:47.
Yeah, we're just about onto question time, and we've got a couple of questions that have come through on the portal.
Okay, so I'll just so this is the report that we've developed. It's the PDF version, so you see it's similar to the one I showed before. You click on the hyperlinks, it shows you the view of the thermal model, gives you that calculation, and then gives you a summary of the elements that are in there. This gives you the breakdown of how we've arrived at the R values. So this is from that spreadsheet I mentioned, we pasted into it. And then if we jump through to here, this shows us the preferred costing. And then at the moment, we're clipping and pasting the scenarios that we've gone through into here. So to give you an idea of the scenarios we've done. A little bit of a formatting issue there that we was working through, trying to get all of this working. If this was printed, you'd still be smelling the ink, because I got it from the programmers about 11:30. So yeah, this will be what you get. And then so this is the web version. So it's pretty similar to the report, but you can navigate the model. You can choose what you want to see in the model, and yeah, it looks like it's. Oh, yeah. And then you can look at charts, give you a breakdown down the bottom here, gives a cost breakdown. So this is at what we call the client level. So it's showing the sell price, including margin and GST. But this sort of just gives you an idea of where we're going to with the web one. So what we're looking to be able to do is you push it from Revit or ArchiCAD across into this, and then to be able to start making your H1 design decisions within this. Okay, Kevin, so over to questions.
Well, great. Thanks, Nick. You have certainly warmed us up for question time, and we've got a couple that have flowed through, as I mentioned. And we'll start off with a question that's come through about the development of the software. The question is, have you thought about including orientation, external shading, and cooling loads into your model?
Yeah, so that's getting into the thermal modeling space. So part of the work Ali did when we first started working on this was looking at what do we need to do to be able to make this service viable, and and looked at what the alternatives were for thermal modeling software. So do we license somebody else's software and use thermal modeling to provide the service? Do we do calculation method? What's going to be the way? What we identified out of that was calculation method was something that we could achieve within our system with a relatively some work, but relatively minimal amount of work, or an achievable amount of work, I should probably say, rather than minimal. Those things you're talking about are getting into the thermal modeling space. The challenge, in theory, it's an option for us to do it, but I don't know if I'm ready to try and attempt developing a thermal modeling system, which is what we would have to do. I'd be interested in it, and it's something I'm trying to get to talk to some big brands. They're not very good at responding, to see whether there's any way of doing things like the heat loss, heat gain type, an equivalent calculation method of that can basically, obviously the calculation method's got a whole lot of assumptions built into it that somebody's researched and developed. So it becomes like an analog of doing the thermal modeling process, and obviously they're confident enough that it's near enough to give a reasonable set of information for decision making. And if there's something similar to look at shading, heat gain, that sort of thing, then it's potentially something we could build into the system. I certainly can't see us in the short, even medium term contemplating building a thermal modeling tool. So long answer, no.
That's all right. We appreciate you sharing your expertise and knowledge with us. And coming back to thermal envelopes, I got a bit of a hot question for you, if you like, with this one. So hang on. It seems quite dangerous to specifically design a thermal envelope based on lowest cost and minimum H1 compliance requirements. Surely the thermal envelope of a building is far more complicated than this, and there are other factors that need to be considered, for example, condensation or health benefits. Do you have a response to that? I guess it's more of a statement than a question there, but
Yeah.
any views
I,
on it?
I absolutely appreciate the sentiment behind it, and you'll notice that I've not used the word lowest cost at all through the process, because I don't think we're actually trying to achieve lowest cost. What we're trying to do is achieve more efficient buildings, and efficient is what are the desired outcomes. So if your desired outcome is lowest cost, then that's one way of being efficient. But if your desired outcome is a warm, livable home at a reasonable price, then that's being efficient as well. So I'm not suggesting we drive everything to the lowest possible cost. But if you don't know what the cost is, you can't make any, to me, you can't make any effective decisions. So it's about understanding those trade-offs between the options and what outcomes you want to achieve. I guess, does that answer it?
I think so. Thank you, Nick. And I appreciate you taking that question head on from the audience. Really appreciate that. Now, one of the other advantages of having someone like you on the call is we get a chance to get some outside perspective on working with architects. And the next question looks at that. The question is, what mistakes do we architects make when looking at higher performance passive design versus building cost? For example, what can we do better, building systems or processes, to maintain high performance H1 values, but keep build costs low?
It's a really good question, and my answer is I don't know. And what I'm hoping that so the issue is going to be knowing all of those things. So we've now built the tool set that allows us to know it, and we've done that limited range of scenario comparison on a handful of buildings. I think it's going to take some time for us to understand where those opportunities are in that design performance cost sort of trade-off. And I'm hoping I'll be in a position to be able to answer that better as we do more projects. I don't know if I can say too much more. Hopefully that gives you an idea. So I think there is going to be opportunities there, because I'm convinced enough there's opportunities there to spend all this time and money building this service. But exactly what they are yet, I don't know. I'm hoping to uncover them.
And looking a little bit more at the product and the way that it may change with time. The question from the audience is, what target market is Hive looking at, i.e. group building or high performance? How will the Hive develop over time?
Yeah, I think it's a good leading question. So in terms of your QS, we do very little with group builders. I think this may actually be a value proposition for us to them. So I think, I guess technically they would have the ability, because they do their own, a lot of them do their own costing in-house, as good or bad as it is. So that's maybe something we do with group builders. Our customer base is I guess you'd say bespoke homes. So most of the builders and designers we work with are designing their own homes. So, or designing non-semi houses. So yeah, that's basically where our primary focus is, because that's where our customer base is. So basically looking to help work with designers with bespoke homes and try and make those more cost effective. So achieving the outcome they wanted for less money, or achieving a better outcome for the same money. I think that covers it.
Yeah, I think so. Thanks, Nick. And I'm always interested in these homegrown Kiwi technology success stories. So thank you. Oh, we've got one more that just came in. Hot off the Slido press. Based on your experience, what are some of the more common misconceptions architects have about what is a cost-effective solution?
Yeah, that's sort of almost going back to that one, as I don't know. So while our system's got the ability to cost, gazillions of permutations of things, or 99.9% of the time, all we're doing is costing whatever's in front of us. We're not going away and working out what it could have been, because nobody's paying us to do that. And effectively the service is going to be people paying us to do that. So it's going to be a learning curve for us. And certainly the reason why we're focusing on this H1 thing is I realized through that what we discovered at the end of last year around the decision making, that there was an opportunity, and from a technology perspective, it constrains the problem down to just these elements, so walls, floors, windows, roofs. And in terms of getting this interactive, sort of smooth process going, we can focus on getting it working for those elements rather than the whole house. But ultimately, I'd like to get to the point where we've actually got the same process in place, that you're able to push the model across into our system, and it costs everything and gives you a complete build cost. It'd be, I guess, the holy grail at the end of this. I can see the technology as to sort of how we can get there, but I know there's lots of issues that we need to solve. There's lots of things that we do when we get that 3D model in to our process. There's a lot of things that we do, a lot of information we add to those models that currently designers aren't adding. So I've got a lot of work to work through to do that. So it's I'm hoping to learn a lot more about where those optimization opportunities are. I guess the one that I've seen so far is edge installation isn't a very good option. So edge installation is pretty poor bang for buck in terms of improving the performance of your building. So that's one thing we've picked up through what we've done. And I'm hoping to learn a lot more like that. I guess touching on the passive house thing. So we do quite a lot of passive house for builders. We do quite a lot of high performing homes. So sort of people that are wanting a passive-ish outcome without going down the full passive house route. So we do a lot of SIPs. We do a lot with vapor barriers, heat recovery systems, and the like. And we're also collaborating with Jason Quinn from Sustainable Engineering. So they do the thermal modeling of it. So the discussion I had with him is, he said, look, I'm interested in the 2% that want to do the thermal modeling. So if you strike those, fire them our way and we'll collaborate with you. So I'm going to have Jason review all that we've done, just to make sure there's no holes in our process or mistakes in what we've done. We're sort of on the fringes of the passive house world, but the service isn't oriented at passive house per se.
That's great. Thanks, Nick. We'll have time for, we've got one comment and one question, and then we'll wrap up for today's session. But first is a well-deserved applause. Just a comment. Thanks, Nick. Appreciate the development of this tool. Well done. Appreciate it from the audience. And then one last question. High performance building. Will your system work with stated R values on plans and provide more affordable options to achieve those R values?
Yeah, I guess we could. Yeah, that takes away the opportunity to trade off between the different components of the buildings. But yeah, if you say you wanted an R value of 2.8 in the wall or whatever, we could work out what the alternatives are as to how you could achieve that and give you an idea of costs for them. We could.
Great. So some opportunities for future enhancements there. Thank you. We've managed to clear the queue on the questions today. Nick, thank you very much for your time and contributing your knowledge and expertise. On behalf of the Institute and our audience today, I just want to thank you for your time and sharing your knowledge and insights with us today. And I'll remind any members, if they're joining online today and have any other questions that we weren't able to get to or would like to get in touch with us, to please email our team at cpd@nzia.co.nz. But that's it for today's webinar. We're finishing just bang on top of the hour, right on time. Ka kite, everyone. Thank you. We'll see you later, and we will look forward to seeing you again soon on our next webinar. Cheers.